5, 4, 3, 2, 1. Hello everybody, I presume I'm streaming, and that countdown will actually let me know in the future. I'm also going to go into my Twitch app, go to my profile here to see if this has started. Yeah, there it is. Talk about recursion. This is recursion within recursion. I'll put that aside, and doing an Alt tab, or a Windows tab actually, I got to get my terminology right. You'll see that I got my standard little ribbon, and I've got Twitch Studio running here over in desktop 7. I just put it as far to the right as possible. I keep it running full screen. And besides that, I have very little running. My traditional full screen Linux terminal, which is under the Windows subsystem for Linux, here with my journal in Vim running full screen. And on the screen to the right of that, Jupyter Notebook from my last session. We left off with persistence, and I have just cleaned up the repo a little bit. So if you're following along in GitHub, I have the persist and persists functions both in here, but they're also part of Pipulate, which is how I'll be using it now. The point there being that easy object pickling is now part of Pipulate, and I'll be using that in my API. I'll be using that API now for my pickling as I collect SERPs for keywords. Now, I'm doing this whole project. Okay, I guess time now to do the screencast portion of this. I'll go to one of the open screens, and I brought this little scribbly thing up now onto my Windows toolbar with the understanding that I can click that. I believe I can. I do not seem to be able to click that to bring up the options. Oh, there it is. So I can whiteboard. Ugh. Okay, so maybe it's a firm click. That brought up the toolbar option like a right click. Let me do that one more time. I'll do it with my finger. This is worth it because if it works, okay, now I can either whiteboard or do a full screen snip. I will try whiteboard. This is a new thing that got installed when I brought back that little scribbly app. And this, I could do collaborative whiteboarding, and it might be my solution to fast writing on the screen to give you ideas. So today, that does seem to be taking a long time. That is unacceptable. I'm going to quit right out of that. Don't even give that a chance. I'm just going to type it. So much for whiteboarding. I'll work on that again. Today, we are going to do SERP-scraping. And we are going to do that primarily carefully. I can see my system is slowing down quite a bit, having done the last few things I did. Hopefully it's not dropping frames on the stream. So, carefully. And that's what the object persistence was about, because you only want to SERP scrape once. So to get right to it, we're going to go back into my home directory of this project, GitHub Python SEO, which you can find at nick11/Python SEO on GitHub. And I'm going to make a new file. Start with fresh thoughts. And now that I have all this stuff here, all I really need is the importing Pipulate locally to get started, because that provides the easy pickling interface now that I'm going to be using to save my SERP results. Streaming does definitely take its toll on your CPU. This is the same, by the way, as import Pipulate, which most of you will be doing out there in a little while after I update Pipulate in Pipulate, where you can install with pip install Pipulate. Now, when you're doing that from Jupyter Notebook, it would be with this other, it would be this exclamation point before it. And as you can see, it outputs that twice. It's because it's doing a reload of Pipulate here. And so if we executed that again, it'll be slightly better to look at. So I do that as a alternative to import Pipulate. I'll document it here, right in context. The below code is my developer alternative to import Pipulate, which most of you will be doing later on if you're actually following along. If you don't have Pipulate, you would pip install Pipulate to get it. I'm going to get rid of that. I'm also going to stop the streaming on my phone so that I'm not using my bandwidth to pull down the very video that I am broadcasting. I don't want to create any sort of recursion on my network. Think about those sorts of things. So, import requests. This is that moment, right? That I've been talking about how Pipulate is a tool for all this stuff. It's a Swiss Army knife. So I'm about to put SERP-scraping, lightweight SERP-scraping that you have to use a little bit of your own better judgment and caution in using. I sometimes use this with VPNs, virtual private networks, so that if I get an IP ban, a temporary IP ban from Google, it's not against my personal IP, but we're not going to really be doing so much SERP scraping that's really ever even an issue. Big jobs, yeah. Small few jobs, no. Small few jobs where we take the time to cache, definitely not. So let's see. Let's import requests, and now we want to construct our query. And for example, if our search is going to be on Mike Levin SEO, the URL, I guess I just switched that data type, that can happen. My URL is going to be, if I remember correctly, https://www.google.com/q for query equals Mike, and pluses become spaces, Levin SEO. And that's just a URL. But now if we do request.get, we actually want to set something equal to that, traditionally R for the requests object, which really stands for result, right? I'm going to be a little more verbose so that you know what you're looking at, right? If you're getting a result from the request.get object, let's call it a result. And we're getting it for a URL. So now we have sitting in memory a search result, 0404. Okay, I didn't quite get it right. There's always a question mark before a search. 200, right? So 404 was not found. 200 is found. So there is a result.txt, believe it or not, or text, T-E-X-T, which is the search result. It's all hidden in here. The search result on Mike Levin SEO is actually in here. And we're about to do an extraction process to get it out of there. And I'm going to show you the code that I'm actually retiring. By the way, this is very equivalent to if I went into a browser like this and typed Mike Levin SEO. Here's the search results. And you can see I don't have my normal 100 results because I opened in incognito mode. But now if I view page source, this view page source is pretty much the equivalent of what you're seeing here. About the same amount of code. There's the end body. Now, instead of making you suffer through deciphering all this, I will, in fact, be bringing up the last repo that I used to do this kind of work, called Simple SERPs. And I'm going to be getting the pattern out of that in order to grab the search results out of here. First, we should, before we even do that, I should show you how I bank these results. It's sitting in result.txt, and a restart or something of the notebook would lose all that, and I'd have to hit Google again. And from here and from that incognito window, I've already done it twice. We don't want to keep doing that. So I am going to pipulate.persist the object, which is a result, with a file name. I'm going to call it, I want to use SERPs, but from past projects, I had put some of those in there. So I want to delete everything in this repo, cd. That's not Pipulate, it's Python SEO. I want to delete everything in this thing that has .pickle in it except for credentials. So that's actually a little bit annoying. File name.pickle, Monty.pickle, serps.pickle, serps.2.pickle. And there, now the only things in here are default, which is going to keep getting overwritten as I use this without a file name. I'll leave that in there, and then I'll keep that there. And in fact, I will do make dir SERPs. So inside of Python SEO, I now have a SERPs directory, and I can cd into SERPs. Now here I'm going to do something that is a little bit operating system dependent, but it's worth it for the win here. So I'm going to do SERP / you'll notice, even though I'm on a Windows system, and we'll talk about that later and how to make this more robust than a / because there is ambiguity with me being on a Windows system where everything is \. But I'm going to do, I'm going to name that mlseo.pickle. I can use anything I want, so pkl. I'm going to keep it short, so deleting stuff is not going to be all that hard. So no such file server. Okay, so we make it persist, we push it in. Let me try it without the, well, let me try it with a path location, like from where I'm at. Nope, no such file or directory. Now, pipulate.persist should not actually require loading the file. It should just write it out. I'm going to try doing it without a path to see if I'm encountering something strange there. And I am. Okay. So paths are always a tricky issue because of operating system dependent issues. And I'll be using the path lib pretty soon. But for right now, I have created this file here, ml SEO. And I'll get rid of that directory so it doesn't confuse me. So much for organizing it into directories for now. But I can now set any arbitrary, value into pipulate.persists. Just drop yes in there, and it knows it persists, and you actually only have to feed the file name in that case. And now R2 is the same request object, but now I can just get it whenever I want. In fact, to make that point completely, I am going to do a kernel restart and clear output, and then I'll start to show you how these notebooks really start to clear up as you don't have to run the lines independently from each other, but rather you can put all your imports together. Emojis. Set your query. Make your query persistent. Delete all this leftover trash. And there, see, things start to get to be nicer to look at. But the happy fun thing at this point is that I don't even have to execute all this stuff that fetches the search result. All I have to do is execute this one. Oh, well, I have to import Pipulate. So I do have to execute this one up here, but not this one, which is the one that executes the search result. This is the one you're trying to avoid having to do. Now, again, Pipulate, the reason this import is a little bit long is because of the amount Pipulate does with Google OAuth authentication, which comes into the picture a lot later. And I run it twice just to get rid of the second output. It doesn't matter. You can re-import modules as much as you want in Python. It's one of its key strengths. It makes it really for this Jupyter Notebook environment, read, execute, print groups. Okay, so here we have the search results in this object here without having even executed the search on this latest Python session. So that is that first step having to do with safety, which was the whole point of doing object persistence first. Okay, that's ugly to look at. We certainly don't want to look at that, but we know we have this object. What I'm going to do now is go into another repo that I keep, which is called Simple SERPs. And I'm going to go into Simple SERPs for just collecting the SERPs. And then there's another Simple SERP-G sheet, which uses the Google Sheet connectivity of Pipulate in order to push the results back up. We're going to not do G sheets yet. It's just too many moving parts. We're going to just focus on executing searches and storing the information locally in Pickles. We'll put it in a Google Sheet as its own sort of separate thing. Now, this is my old code for running stuff and dropping it into a local cache. And I have found it a little too difficult to look at. And it causes a little bit of stress to have to interact with it all the time, mostly because of the caching API and a lot of the overhead I did here for keeping track of things for long-running repetitive jobs and stuff. And I really don't need that much. So I'm going to try and make, we don't need persistence anymore. I'm going to try and make that file that does the SERP scraping as little code as possible and externalize most of the heavy lifting that we need to do into Pipulate, so that what you put in your file, which is here, it's this untitled one, which we have to give a name, will be as little code as possible to do this type of SERP work. The less code you have to look at, the more sophisticated your algorithms can be expressed, because you don't have to deal with all the housekeeping, which is moved off and externalized on the other side of these API commands. That's what's happening here. It's hard to even see that pickling is in effect. And you don't have to deal with pickle.dump, pickle.load or load, singular versus plural. There's just all this stuff that, this is why requests exist. Python natively is perfectly capable of doing all this URL manipulation, but this is promoted as HTTP for humans. So all you have to do is a little command like this to do an actual search in Google. Next step is to pull out from Simple SERP the pattern that we need to do. Well, first of all, I am going to import RE. I'm going to start stacking all my imports where they occur and re-executing it, because why not, right? Pipulate import isn't really that long anymore after you did it the first time. And so now I have RE, which is the regular expression. It's interesting that regular expression and request objects are the first two, or external packages are the first two things to use. This is in the standard library, this is not, but you have it if you're running Jupyter Notebook, from an Anaconda install. So you don't have to pip install requests, but it's worth knowing that it's not part of the standard library, even though that's a controversial topic. A lot of people would like it to be. It's not, because it's being kept alive. Let me get the guy's name down. I refer to him all the time. Kenneth Wright. Interesting guy. Keeps himself hydrated. REITZ, Kenneth Wright. It's worth following him on Twitter and everything. Very influential guy in the Python community. Okay, so this is going to be SERPs. It's going to be SERP-scraping. Let's be more SERP-scraping. That will allow it to be really clearly identified. Git status. Oh, look, a new file. First, we'll filter out the PKL files, vim.gitignore. And, you too could master Vim. Text editing is fundamental to text, to text. See this wife, life, these channeling things. So the only new thing is SERP-scrape. So I'm going to git add. Git add SERP-scrape. Git commit added SERP-scrape. Git push. It's committed. That is now out there and up in GitHub. If you're following along with my work, it's just github.com/mclevin/Python SEO. I happen to be looking in the persistence file. I could knock that off the URL, go to the repo directory itself, and you can see there is SERP-scraping. You can see it with the NB Notebook, NB Viewer mode, which is built into GitHub, so that notebooks render and appear much like they actually do right inside of Jupyter Notebook. So this is another way to follow along if you're interested. All this code is accessible. On occasion, I'm going to be pushing this work up into PyPy so that it's actually available in the version of Pipulate you too can install easily. It is not yet. So next step is going into that simple SERP scraper. I loaded that. That file is right here. We are looking for the regular expression pattern that extracts the keywords from out of the search results. And you'll remember there is still probably view source in that other anonymous one. And before I go lifting up out of my document, we'll just go look for Mike Levin. And there's a search result, right? Because I'm rigging this so that we can see the search results. Value, we want to look to see if it looks like a search result. And I don't think it is. I'm going to go forward and we start to see stuff. Site. Yep, there's my site. That's going to always be one of the top ones. And you see all this gobbledygook around here that makes you wonder how you're actually going to pick stuff up. And I had gone through this thought process before figuring it out. Tempted to just go over to my code, but you can always find some object structure in here. Class equals R, probably for results. And there's like an actual structure in here that can be deciphered, but instead of wasting your time on a stream, I will in fact go back to where I figured this work out before and find the patterns. Pattern equals re.compile, and then the result divs I extract out, find all of that patterns in the text. It's really that simple. I mean, it's magic incantations, but isn't it all? Now, why not go with response, right? Change it here instead of down here because response keeps it as a really good language. Now we have an object called response that we can feed into that. And now I have result divs. Ah, empty. Okay. Well, we look things over carefully. Re.compile div class R. So I'm going to check for that in my code. Result divs, and make sure I'm really loading search results for Mike Levin SEO. I do believe I am. Because I put it onto my machine using that, pulled it off of my machine using that, and we can look at, nothing's ever a mystery. Part of how this works is that, tons of people would go, well, it's a mystery to me, but it's not, because you can go response dot, and do a dir on that. See all the stuff that's in it. One of the things that's in it is going to be text. And now we can just do a control F on the pattern that we're looking for and see if it can in fact be found, this part here. And no. So div class searcher, I might either not be looking at the search results. I think I am. And I think that's the case. This does not look like Mike Levin search results, right? Mike space Levin. Oh, there I am. SEO. But I think there would be much more in here than just the one occurrence, especially of, say, just my name by itself. Yeah, that's not search results. So I double check the URL that I used to do it. Spelling out search. Not just Q equals. Still no. Let's take a look. Oh, result divs. Response equals response.text. We make sure we're not doing the stupid mistakes. See if that looks longer. That looks quite a bit longer than it did before. I am quite a bit more hopeful. I might have just gone too fast a second ago. Take heart. The more successful we are, the less code we're actually going to have to look at. So once again, I search for this guy here to see if the pattern for scraping, and it's sometimes kind of like an arms race in SEO. The two that are registering are the two that are actually in here. So we triple check. Now I look for these results, my name again, and see if it's just, no, it's a lot more now than it used to be. See, so we're on the right track. Now to extract the SERPs from out of here, div class So there's a few tricks that can be done. There's one that I'm thinking about possibly doing, which is pretty printing this to get some sense of indenting and everything. It is in fact a Google search. We did re-execute it. We dropped it onto the hard drive. We loaded it back out of that location. Result and response. So I use result here. I use response here. Pattern equals div class. So we want to find the first search result. We can actually compare it to, we have the evidence of what's going on here. And this is what the live streaming is about, right? I'm not trying to make such a polished YouTube video. So every time it goes, bold, it probably is a break in the code. So I want to actually search on a piece of code like this. See what it looks like doing it here. And then jump back over here and do the same thing. There it is. Okay, so we're sitting on some good stuff. And there's the micro 11. And so these classes, divs, and client. Okay, SERP-scrape. Lots of fun with SERP-scraping. Whoops, broke that out into its own. I didn't mean to do that. And we'll make sure we don't look for any other patterns first, but I don't think we do. The results. And then we step through the results, but I should be able to get that same result. And that div that I'm looking for that contains the results might have recently changed. So we have to be adaptable. And, that's a very specific search. If they're still using class equals R for class equals results, a smaller search like that will show it up, and they're not. Now that's a div that contains all the search results. So I'm going to try and do a pretty print of this and see what happens. It's a built-into Python measure you can do to try and clean up things and get some sense of object structure. From pprint, import pprint. Now that is just getting an easier thing, so I don't have to type pprint.pprint as the way of using this. Just put preprint around result.txt and things get indented a little bit better. We can look at some sense of structure to this, right? A lot prettier. And in fact, I will look for my consultant, the first SERP result. See, there's the first SERP result, and it's a lot more structured. That all lumped togetherness is sort of undone. And we look for the patterns, our eyeballs pick it up, and you can kind of see the search results there as they would appear in the top 10 list, and then it gets outdented a little bit more as we go up here. And the idea is we're looking for a parent object that contains everything so that we have a smaller selection of just the code that is responsible for the search results. Class, there's some weird classes here. I'm going to look through those classes and see what we got. I mean, there's a lot of them, but their meaning has been a little bit more obfuscated than it perhaps was in the past. But you can see we're in the neighborhood. Another thing we can do is is go back to the actual search results and right click and use the object inspector. These types of structures that are sometimes pretty difficult to see in tree form are easier when you sort of twinkle through the results. You now click that guy there. Now you mouse over the portions. And the trick is we actually want this one that gets all the search results like that. Look at those. I'll click on it, go here. You can see that that div now contains all the search results. We're going to expand that by 1. Highlight the portions in there. Interesting, interesting. Wow. ID equals RSO results. Okay, there we have it. Instead of class equals something, we're going to do ID equals RSO. So instead of just lifting the code from my last project, there's been changes in SERPs since then. So we are doing a little bit of adapting on the fly, and that's good for this live, Twitch streaming. So RSO, instead of class equals R, it's not even necessarily div, but let's check. Compile where I should probably put this anonymous window onto the second one. That's this first one I'm looking at. It always goes to the left. I put that there. Now it's easy to go back and forth without the struggling. See, these are the tricks of the virtual screen. Yeah, so the pattern is going to have to be quite permissive about what comes in between the div and the IDRS, because it is over to the right, IDRSO. That pattern now is going to be something more like div followed by a space and then any number of characters, but on the greedy side, and ID equals RSO for results. And then again, and matching anything but on the greedy side, but with parentheses around it to make a matching group, which is what we're actually interested in this case. Okay, still not there, but that's okay. That'll be just a little bit of refinement here as I figure out why that match isn't occurring. We want to look for IDRSO in the actual view source. Okay. And it goes across line breaks, which is definitely factoring in here. Oh, look at that, div ID equals search. That's an easy one. Ooh. That's a little more like it. Now there's an object that can be stepped through with another search, because it's sort of narrowed everything down to just the search results. So this was sort of a paring down, and I'm printing result divs, and that's a list, and I want to take a look, see if I have separate results. Well, first let's just do a length. If it's, yeah, length. It doesn't give a nice list length, so we can see that's probably just one block of code in there. So I'm going to have to do one more sort of thing in order to make that into a list. It's just a paring down. The result is probably a misnomer. have the result divs in here. Oh yeah, now I want to p-print result divs. Since it's text-like. Oh, let's take a look at result divs again. Whoops. Ah, it emptied. Oh, maybe I didn't have it there before. Maybe I got the pattern wrong. Okay, so div ID equals search, matching group, greedy to the closed div. The things to keep in mind are things having to do with multi-line stuff. So that failing is almost, impossible given what I see over here. It's definitely a match. It's definitely in there. If I take a look at the code itself, then I'm doing the pattern match again, response.text. I did a control F. Looked for this pattern. Oh, just one of two. Interesting. We might have different code here than we have in the view source over there. That is very possible. We want to see if it is at least equivalent. These might be new changes in the industry, keeping up with the Joneses type stuff. Other stuff to look at. Div ID equals search. This is the exact query that was used to produce this, although there's all this other stuff going on in there, but that's generally not necessary. But I'm going to make sure that the query I'm executing is in fact the same as I am doing here. Yep, it is. And the search results, these get into the issues that you're going to find in SERP scraping. Google completely has the ability to detect, say, the requests object versus a genuine Chrome instance. So let's look for where the ID equals search occurs and see what else might be close to that top stuff. Search. Object that comes immediately before where the SERP results kick in, and this says video and stuff, so that's not really the SERP results. These are definitely the search results down here. Just went back up to the beginning, so I page down. we're looking at two different things. What was fetched by the request object here. Now, here's a thing. Okay, all that lost time. Well, better me losing the time here than you losing it. Remember here under simple SERP, the reason it's going to be different is because of all this user agent stuff. So whereas I just rushed ahead and did I should know this having done this for so long, having just done a request.get URL, there's a reason I have some of that gobbledygook over here, and I'll probably be able to use the same old pattern as I did here once I tell it what browser I'm using, because it does in fact change with your browser. So these are a bunch of user agents, and I create an agent cycler using the cycle object, which is imported up here. And I'm going to do some of these things because we do need to use different user agents. And I'll explain what this list is doing and what cycle is doing. So let's put the cycler up here. Import that. Now we have the cycler at our disposal out of the iter tools. We're now going to bring this in. Now it's going to be applying something to cycler called an agent cycler. Every time agent cycler is called, it's going to use the next one in the list and then go around to the beginning. So it never looks quite the same. I guess I'll put it right here. And now, instead of just request.get URL, we're going to send user agent stuff. Request.get headers equals user agent. Now what's in that? Now what's in that response.text is going to be a lot more logical. User agent. So I set the user agent variable using those things from the cycler. This is my most current work. This is where I'm borrowing from. Agent cycler. User agent equals user agent colon agent. I have to find what agent is. Yeah, agent equals next cycler. See, it all sort of makes sense. Now, my original pattern should probably work. And I've changed this from what it was. This would benefit from a bunch of undos. Well, I guess that doesn't have any undo buffer, but that first pattern is right here. Sorry I wasted all that time, but I guess you would be doing the same. But having gone through this sort of stuff a zillion times before, I generally know what's going wrong. You can spot it. And what was going wrong here was the code was different between this local thing and use source over on a real Chrome instance. But now that I understand I have to feed user agents to search, here's the first round of extracted search results. These are the result divs. And now it is a list, and it does in fact have a length. So 9. So that sounds pretty reasonable because search results, 10 results per page, a lot of volatility lately and how that really is out. So 9 is a reasonable number to expect. And we're absolutely going to be doing, for div in result divs, print div. I'll just print div as a stand-in, but if I do another print statement after it, to put spaces between them, there's other ways to do that. This is the easy way. You can now kind of see what's going on. Each one of these extracted divs has code in it in turn, but it's now really easy to extract against that. It's going to be another pattern that just looks at these tiny little encapsulated bits. So let's actually do that, and then that'll be me wrapping up for now, because you'll have the SERP results extracted, and we'll be able to drop those into a cache as well too. And now you won't have to be rehitting against Google search in order to do experimentation. I'll set maybe results per page to boost it up to 100. But now let's go into my old project. We're going to look for the other pattern for a result in result divs, right? That looks familiar. The pattern URL, the URL group. I grabbed the title as well. Yeah, try things. And there's a lot that I'm really doing there for the result tuple. You know what? I made you sit through enough agony before. I won't reinvent the wheel. I'll lift that up. It's the smallest bit of code that probably I'll be directly lifting. For a result. Okay, that's something needs to be done here. Expected string or byte-like object. Okay. That is on the URL group equals. So I copy that much. Put that on another code block. I get the error again. That's okay, because now I have that much less code to look at in diagnosing the error. For a result in result divs, pattern URL equals re.compile, nice simple pattern, and then, an attempted match. So first let me make sure that that is a good pattern to be using. I actually want one of those result divs. You can look at a single one by going like this. That's the what's in that single one. Now it's a tuple. And inside that tuple, we are in fact looking for a href equals, just like it makes me think. Oh, there's an h3. Yeah, that's not. So a href equals, the matching group. The use of double quotes around it. And then the URL group equals matching the pattern URL against a result. And the error is expected string or byte-like object. So, what is that? probably going to be a tuple because I can see the tuple syntax around it. Yeah. Okay, so there's a mysterious object that I could try and filter out of this tuple, this first object, but it's a matching group. So there's two things that are matching, one that was empty and one that was that pattern. So it can't be empty. Ahref equals, it must have, this is two accepting dot asterisk. It's got to be at least one thing in the Ahref. And I believe instead of the asterisk, let's see, might be the plus sign. No, it's in this first one that the two permissive class equals R. Oh, two different ones. I see. Typing mistake. Just a typing mistake. I had two matching groups. Now it's gonna work as expected. Live. Okay, the results is not defined. Much better. The results not append. There you go. Now the URL isn't showing. Let me double check against that original pattern. Yep, it's a single one that I had thought. And then this next pattern here. Okay, that's a good pattern. And then the tuple is being constructed. Oh, well, these tries are always suspicious because the tries might in fact fail. I'm trying to get the title at the same time is what I'm really trying to do there. Pattern URL equals that main pattern for result. Okay, the URL group equals right there. Title equals h2, and then I'm constructing the tuple. Try the URL 0. We definitely want to eliminate these tries to see what's going on here. It's going to create an error, but we'll also clarify the situation. Untype object has no attribute groups on the title equals. So some of these are not going to have a title. So was I getting the title or the URL? That is the title equals. If I edit this out, you'll see we get much like what we did before because the URLs are being extracted correctly, but it appears that the titles may not. So that try is actually perfectly acceptable for the URL. But now we want to clean up what's happening on the title. The title equals the title group. Title group was established here. Got groups. Well, you know, this is a REPL environment, so we can look at first the title group of the last one it hit on going through the loop. It's empty. So the title group using this pattern h3 cletnet, and you would think that'd be fragile because look at that that weird class in there. I'm going to loosen that up. Do we really need to do, yeah, we want the URL in the title because it's carried there, so why not? But the title group is coming up empty. Let's print that on each iteration. See, it's none, and then an error. So it's just not matching. So you can, I guess, look at the view source and, well, not view source. We don't need to deal in view source. We just look at a single A result, which, because it's a loop and it exited out, will be the last one it encountered. A href, we're grabbing this OK. Now there's a headline in here. And in this case, my headline is probably very simple, just my name or something. Site class. That's probably it right there. Site class. Any other candidates? That's the only candidate. So site class seems to have changed to be the title. At least in this case, there's probably multiple SERPs we can reach in and get. But let's just get a site with anything up to the closing parenthesis. You'll see me change a regex pattern, right? It used to be an H3. Site. The space is allowable. It's always going to be there. Something greedy, but not a capturing group because no parentheses. We'll cover all that stuff later. And then end site. Much better. Okay, but printing that whole title group is not really the useful part. Watch it execute like that, and there we go. URL, title. URL, title. And it's a really, really nice shape. And I guess what I was doing before with that appending, it's going to be a result tuple. But really, I'm going to use something different because it's a list of tuples. When you make that a list, which you can do like that, or alternatively, it takes more to type, but you can see that it's an instance of a list object. And now each time you encounter a nice tuple result like this, you append that tuple result, list of tuples, append result tuple, and at the end you can print the at the very end outdent. You want to print the list of tuples. To bring back the try, because this will in fact fail on some occasions, and it's better to have a space than nothing, and run that. And here is a list of tuples, which you can do such creative tricks as, I'll give you a little bit of list comprehension here. First of all, list of tuples. It prints a little bit differently with and without the print statement. With the print statement, it's sort of unstructured. Without the print statement, Jupyter Notebook steps in and does a little bit of built-in pretty printing. And I could do, by the way, for a tuple in list of tuples, print a tuple. Okay, so you get back sort of control over the formatting. I could just as easily do things like this. X for X in, that's list comprehension. It's just another way of stepping through it. And because each one of these is a tuple, and you've exposed the internals of the list using list comprehension, if you wanted just the URLs, you would do that. If you wanted just the titles, you would do that. But this is a valuable object we're sitting on top of here. So what is the natural thing to do at this point? Capture it. So whereas before we used, and we don't need any of this anymore. I'll get rid of that incognito mode. Whereas before, we used the name mlseo.pkl, that stands for the raw SERP results. We'll use extracted. Now this has a little bit of refinement to be done, but extracted will be our file name. So what I'm really doing is pipulate.persist, because we want it to persist. List of tuples extracted.pkl. That's about as easy as it gets for committing something like that to the hard drive. Extracted.pkl is right there. And so with all this Python for SEO stuff that goes on, that you'll be hearing about, it's important to understand that sometimes the most simple thing is to just have control over the ability to run a SERP once and to sit on results and to extract it and run different patterns against it without having to rehit and rehit and rehit this is Google. You know, just hit it once, get what you need, plop it onto the drive. Now this is kind of ugly, and my promise has been to clean up this code so that it lives inside of Pipulate real well. So what we're really doing here is we're trying to create a SERP function where we can have foo equal to pipulate dot something, pipulate dot SERP, and I guess it would go something like Mike Levin SEO, and then it would be something like the pickle file that it would result in. So I'll call this, SERP2.pkl. Okay. Now that should result in something in foo. What should it result in? Well, we don't want to lose everything, so it seems to me that we want both the result object from the requests package and the extracted SERPs. So let's first turn what we've done into a function, and then we'll drop it into Pipulate and never have to look at this ugly code again. Deep breath. Okay. Think. 1, 2, 3, and this is where it goes. It's okay. We have the basics in a Jupyter notebook. It's time to move it over to Pipulate. Means externalize difficult API issues. Okay. And as I always say, it's 1, 2, 3, 1. You're always at step 1. And step 1 always happens to be go right. And that reminds me that my latest work is always in tab 1 of the browser. And now go over once more. We're in Python SEO. You'd think that's where I want to be, but I actually want to be in Pipulate. And if you remember, I CD'd all around all that, to get over to that file, but I have a bunch of aliases. So if I just type Pipulate, I'm editing that file. But I don't want to drop anything in there just yet. I want to get all this into a single code block and turn it into a function, right? So I usually go up from the bottom. This is gratuitous. This is not, because it turns it into something on the hard drive. This is because it loads it back off of the hard drive. So this guy here would go under here, This output is gratuitous, and as we lift things up, code gets cleaner. It gets easier to look at, and being in Jupyter Notebook as your primary coding environment becomes more and more acceptable and forgivable. That REPL, read, eval, print loop stuff, very, very useful. And finally, there's very little harm in doing it like this. Now, in its current form, that would re-execute the query every time. So we now want to move all this stuff into a function. It's a little heavyweight for a function, reinitializing the cycler every time. It seems to me that that should be global to the Pipulate file on the outside, and the function should really start down here. So that becomes def. You know what? Just because it's working without being a function at this point, it feels like I should do it in a separate code block and leave that around as the example. Okay, and now this last step here will be, oh, interesting. I'm just putting the SERPs there. I might be wrapping this up soon because it's getting pretty late on a Friday. It's already coming up on 6:30, so I'm going to do a sort of a quick thing this home, getting it working minimally as a function, and then doing the rest of the work later. This is going to be raw SERP, but my idea is actually to do it once. We're going to have the raw SERP there. It's going to be in the word result. We don't even want that. We're going to do one pickle right. Whew, deep breath, deep breath. We have a list of tuples, and then we have the raw object. So I'm going to make a new object. This is going to be both objects equals, and then we have to come up with a data shape. I'm going to, just for expediency's sake, use a tuple. Tuples are good if you know how many there's going to be. I might use a named tuple. I might use a dictionary later, but we're going to put the two objects that we're dealing with here, the response object, which is the raw. See, we don't even need to have that there. We're sitting on it. It's the response object, and then it's going to be the list of tuples. And then we put both objects into a pickle using that file name. And by default, it's SERP default. So I make that function. Okay, invalid syntax. I just left the colon off of the function definition. And now I can do SERP Mike Levin SEO new.pkl. Okay, there's a print in there, but I should see, we don't need this, cd // Python SEO ls new.pkl. Now I'm going to show you it's persistent. Both equals Pipulate dot persists new.pkl. Both is going to have both the response object of the search result and the extracted out SERPs there. See that? So I can do both .0 to get what the request object originally saw. That has a .text. There's the original search results. Or I can do both .1 and have instantly the extracted SERPs, where I can do neat tricks like X or X in, and then just grab, say, the URL. And let's drop it into Pipulate for now. And, well, look at that. I almost made a big mistake. That keyword has to be used here. And I'll do the fastest way to do that. We're going to test it with something different. There's a Mike Levin out there that is very much definitely not SEO. He's a new senator, I believe, in Orange County, California, that has made it very difficult for me to position on just my name listing, recently. So I can load that off of memory, and both of those. SERP. Oh, yeah, SERP. Make 11. PKL. Let's make sure. Def SERPs. We're giving it a file name. Oh yeah, we're not loading it back off. Oh yeah, we are loading it back off. First we execute it. Oh, maybe I just didn't execute the SERP. It still looks like new. Def SERP. Keyword file name. There's the search. Let's go in with keyword. Let's try food. Oh, it's me no matter what. Okay, so I have something going on here that's maybe loading it off of the persistent object. So we want to search for the word persists. Nope. We want to see if we really are executing the search. URL equals that. Yeah. Oh, returning something? It's writing it directly to the drive. We can return both. Oh, this is probably not doing it. Pipulate persist. This is both objects. And it is file name coming in there. Is file name being changed? It writes it to the drive. I'm going to attempt to return both objects and not rely on the pickle for this. New equals. What gets returned from that? And it is still as if I didn't put a new SERP function in memory. Both objects. List of tuples. I'm going to restart the kernel. have to do it from the beginning. We'll do that. Oh, you know what? I'll restart and clear output one more time because I don't want to execute all of that for this sort of debugging. We just want to execute the stuff that is not inside the function. So we execute that, but we can put the stuff we just copied into a separate frame, not execute it, and execute this one. And now I'll attempt to search on the word foo. Response is not defined. Now that is what was happening. Response is not defined. Little errors like that will to you. Yeah, that's a lot better. That's just on the word foo that's being returned. Now both is being set to pipulate.persists, and we can see all the URLs for the first page of results of the foo, which is 1, 2, 3, 4, 5, 6, many less results because it's much more competitive than my name, so ads will be running on it. Now as the final step, I pick that up, I type Pipulate, I go down to somewhere where I think I should use it. I'm going to put it near the top because it's new code and it'll be easy to find if I need to look at it again. Make some space for it, set paste mode. Welcome to Vim, where you have to set paste mode, paste it in, paste, do a search on \T to make sure no tabs got in. And now I can reload Pipulate. This will reload it. This stuff has to be in Pipulate now. That should do it. I'll probably do a little bit more cleaning up later, but kernel restart and clear output. And now with the cleared output, we definitely don't want this in there. We'll add a new block and put it there. We need to do this much here. Not really even all of that, but Pipulate for the function we're going to try. And then we just go right down to here where we did this here. We'll say new 2 equals Pipulate dot Levinix.pkl. Pipulate is not defined. Did that not load? That did not load. Cycle is not defined. Oh, yeah, so I need cycle inside of Pipulate. Guess I want to watch this import to make sure it works successfully. There, we got our little message that Pipulate imported. Now we can go down here and use the new API that is completely externalized. Requests is not defined. Okay, Pipulate now imports requests. Okay. Now this could always be done inside the functions themselves so that requests does not have to be loaded for every use of Pipulate. And I might do that. There's some efficiencies that can be done. No module name requests. REQ import REQ. REQ Boy, this must be large. Much better. Now we scroll all the way to the bottom. new2 equals a search on Linux. Re is not defined. Just about there. Maybe there's some other stuff I haven't defined. Maybe we're not there. Oh, yeah. Okay, so persist now, instead of being looked for inside of its own, inside the Pipulate object, it has to look for it inside itself. So whereas we had the word Pipulate here for that function, we want to delete word. And that should be it, because you can see it got pretty much to the bottom of the file. And there you have it. We have an object called new2, which contains both the original requests object and the extracted SERP results. Well, that was quite a live streaming session, but this is a fundamental building block to so many pieces in SEO that it's, oh, that is that's on Linux, that's right. That this is necessary to build into Pipulate. So let me just commit that now. Git commit incorporated cacheable, I guess that's a word, SERP-scraping. Big moment in Pipulate. And just so that everyone has it, let me cd ... vim setup. Go to the version 3.44. What do you say? This deserves a 3.5. Use my command to do a release. Guess I should do a before and after. If I'm fast enough. .44. And that'll update the 3.5 as we're sitting there. It was fast enough, but it's released. Everyone who pip installs Pipulate will get the latest version of everything that I just worked on, including the SERP-scraping. And finally, git commit. Oh, I think I did the git commit. Git push. Git status to see what I did. Yeah, git commit. Just released. Bye. Oh, that is the Pipulate directory I'm in. CD. Oh yeah, that is absolutely correct. Just right. And then git push. There. So everyone who gets this now from GitHub or PyPy has the latest with the SERP-scraping. Use this power responsibly. And I guess that's it for now. We'll come back and we'll pick up from there, because we have some very powerful tools at our disposal. This will update, of course, to 3.5 as soon as PyPy does its thing. Here, it will reflect the latest. Oh yeah, this is that. We would have to look at Pipulate. Just released to PyPy on setup.py. You can see that the latest is out there. Okay, that's where I'm going to stop. That was quite a
Billy has medicine. I tried to give him his pill, but I don't know how to